Sorry? Okay, what we're going through today is the following. The schedule here, do a short introduction, look at why we're looking at Trojans, brief history of Trojans and covert channels, looking at a hybrid model between the two. We're going to do a short demonstration, and then look at how to take this process a little bit further and possible fixes. Okay, SensePost, we both from SensePost. We're a South African-based company. My financial director told me that if I don't get this in here, I'm not coming back ever. Okay, so I'm going to keep it real short and to the point. We're a South African-based company. We're very small, only 6 people there. We do a lot of external penetration work. And because of the exchange rate, $1 buys you nowadays buys you about 13 Rand. So we do it way cheap. Okay, the speakers. My name is Roelof Temmingh. That's Haroon, Meer. When you get to a company, they always have this kind of thing of, we have a presentation, we have a course on giving presentations. We skip that one. So if the language is a little bit, kind of the grammar is not correct, English is not my first language.
It is my first language, but I suck at it anyway.
Okay, so, and we hope to get the message across, but like I said, we haven't been to that, this is how you do presentation. We haven't been to that course. We're more kind of technical. Both of us have got a programming background, but we're not programmers at this moment. We have a philosophy that says enough duct tape can fix the world. So we generally just code a whole lot of Perl and some C code, throw it together, and see what happens. You might have seen our names in some Perl snippets out there. And we're really more interested in technique and method and very practical in what we do. That's why we have a demo here as well. Okay, the objective of the presentation, what we're going to show you here is really not a new vulnerability of any kind. It's really a new method. It's a way of doing something. And most of the components that we use here is existing components. So you will find this out there on the net. And what we basically just done is wind a whole lot of duct tape around this, again, to make it into something that can show you the implications of what is possible. Going back to that, it's really an awareness kind of thing. We have a strong feeling that something like this is out there, and I think it's a good idea if you know about this. The other thing is also that we want to stimulate the minds of the people here to think about the problem, to think of various new ways to exploit this or to secure your network against something like this. And then to inspire the coders, that's the real hardcore programmers, to basically look through our code and clean it. Because, like I said, we're not really coders. We have a programming background, but we're not hardcore programmers at all. And that's the objective of the presentation. Uses for bidirectional communication. Now, everyone is giving me a hard time about the topic. It says it's boring and, bidirectional communication.
Designed by marketing. Uses of bidirectional communication.
Yeah, for sure. So what do we actually mean by that? Now, normal communications on the internet today is bidirectional communication. That's sending data in and getting data back. When you break into a network, or when you try to break into a network, you attempt to get bidirectional communication with the machine. Now, on a network level, that might mean something like using a source port 20, going to a high port, setting the ECE flag on a packet to bypass the bug that was apparent with the BSD IPFW. That's kind of two-way communications in breaking in. And basically, on an app level, you can have something as easy as the bug in show code to show you stuff. That's data in, data out. When we think of one-way communications, it means we're sending data, but we're not receiving anything back. If we think about something like on a network level, blind spoofing, that's sending data, not getting it back. On an application level, that could be something like doing SQL insertion, doing a SQL command but not getting anything back. We've been looking at breaking into networks. What is interesting is breaking out of networks as well. In many companies nowadays, you have users sitting inside of a firewall and they can't get out. They can't surf the web. They can't just SSH out. They can't telnet out. They can't get out of the network. So the idea for them is to break out of the network. And many networks are better protected from users going outside than users coming inside. So you see that bidirectional communication is actually a useful thing, and it's useful for many different applications and stuff. One of the things we're looking at here in particular is that of Trojans. Now, when we talk about Trojans and you hear the word Trojan, this is actually why we didn't have it in the title. Is you think of stuff like back RFS, NetBus, Sub7, that kind of thing springs to mind. And you also think of script kiddies trying to rip off their buddy by getting the password that protects the NIC on the IRC. Generally, Trojans is considered like an uncool thing. It's not for heavy technical people. I want to jump ahead a little bit there and go to what I call the weirdness in the industry today. If you look at the motivation of real purist hackers, real pure hacker is motivated by the elegance of a hack. Okay? So motivated by the technical cleverness of a particular hack. It's motivated by the problem and not so much about the data that sits behind the problem. Whereas if you look at real criminals, the criminal is not interested in writing a buffer overflow. The criminal is really interested in actually getting the data itself. They want the control, they want to cause damage. They're there for money and they're there for power. They're not there for a cleverness, a technical cleverness. And the industry, the security industry, is heavily influenced by technology leaders. People that think about technology, people that think about the technical cleverness, not so much influenced by criminals. And as such, when we think about IT security, a lot of stuff is just left behind. Physical security is something that is, you guys don't think about physical security. Stolen notebooks, file servers that's just taken out of a room and the hard drive been copied. That's uncool. That's not nice. RAS security is also something that we don't think about a lot. And even data level attacks. Data level attacks means, does it really matter that your web server or whatever is really safe, while the rest of the world thinks that it's been defaced with it, like a DNS attack, a DNS poisoning kind of attack, something like this. And another thing that is also considered uncool in the industry is Trojans. And if you look at the profile of Trojan users, yeah, sure, you get your script kiddies using Trojans all of the time for sure. But the real criminals and the real bad guys, they use it as well. And the other group of people that really use Trojans a lot is the government agencies. They tend to specialize in this kind of thing. It's true. Let's look at some examples of networks taken and by Trojans. You don't see a lot of that because it's not published really, because whoever is using the Trojan is actually after some data, is after some real hardcore data. And it's not defacing a server, so it's not published that much. You see, it's real loss at the company, and the company don't publish that. It's not that cool. And obviously, the government agencies don't tell the world that, we've broken into this network and extracted that and that kind of data. Where it is published, we tend to sit up and listen, okay? The hacker group or the hacker Fluffy Bunny used, amongst other techniques, used a whole lot of other techniques, but he used Trojans as well to gain access to SANS, Exodus, and Apache, the actual source tree of that. And I think, Haroon, you know that the Microsoft guys, there's some rumor that they also got took by Trojan kind of technology. Yep. So this talk is really about Trojans. And it's one of those kind of uncool things that we'd rather not think about, but that's got a real high impact.
Okay, now you know not to trust us if we ever tell you the introduction is going to be short. we decided that we'd also tell you a little bit about the history of Trojans. And the problem that we had was, how far back do we go? So we decided to take it right from the top, start way back at the beginning. About 3,252 years ago, Greek warriors had the city of Troy besieged. The siege lasted something like 10 years. For 10 years, they tried all conventional methods to take the city of Troy, and they failed. 10 years later, morale was low, Achilles was dead, shot in the heel. They were not happy campers. And what this led to was probably one of the most famous gifts in history, where they built their Trojan horse, put their soldiers in it, and gave it to the people of Troy. The model of the story was simply that where conventional methods failed, the Trojan horse led to the fall of the city. About 3,500 years later, as Roelof pointed out, pretty much the same thing is happening. Traditionally protected networks, heavily protected networks, are still falling because of Trojan use or abuse. What we're going to do is go through a list of different models a little later in this, just to discuss how Trojans evolved and why they did. And I think the reason they evolved is pretty much the same story you always see, where necessity is the mother of invention. And in this case, the need was to control a victim's machine. And as security models evolved, the need stayed the same. You still wanted control of this machine. It was just the means that changed. I mean, you started off and things were simple. Everyone was happy, valid IP, no filters. Things changed a little. Stateless firewalls came in. Stateful firewalls were introduced, doing NAT. And you reach the situation where you are today, where there's every device you can think of, monitoring for every kind of traffic you can think of. There's personal firewalls, intrusion detection, content level checks, just about everything. We'll try to skim through these quickly, just discuss a little bit of all of them. With the first model we look at was the model we had way back, friendly internet, no filter between you and your potential victim. All it needed was a bind to a port, do a listen, and see what you want to get. It was straightforward, and the reason we're not going to spend time on it is simply because you've got to get real. My mother uses Zone Alarm. My wife uses Black Ice Defender. Nobody sits on the internet without a filter anymore. The next model we look at is the one where corporates started introducing their firewalls. And there's still a lot of stateless filters out there. And these stateless firewalls allowed almost nothing into the network. So they'd block everything except selected ports. And the problem with this model, obviously, is the almost. You still allowed some stuff in, and stuff was tunneled through the ports that you accepted. There's also a problem with high ports, with selected ports. I mean, one of the leading firewall brands shipped forever with port 53 open by default. Your rule base showed you that everything was blocked. Guys were still coming in on TCP 53. Then there was just TCP flag manipulation. Arne Widstrom wrote an ACK tunneling program as proof of concept. And what it basically did was, you've got this firewall which watches for SYN packets going across because it's stateless, and you only need to block the SYN packets. So Widstrom wrote a tunneling, his ACK tunnel, which conducted entire conversations just using ACK packets. Without the SYN packet ever going across, conversation was fine because the firewall seemed to think it was established traffic. Network security evolved a little bit more. Stateful filters were brought in. Configurations were tightened. No longer could you go everywhere. Use a proxy server if you want to browse. You want to allow IRC? Sure, we'll allow it to these servers that we know about. Networks were starting to get tighter, so the Trojans needed to evolve that little bit again. And then what we found was plugins for like the popular back orifice program. You got gbot and Rattler, which sat on these IRC networks and tunnel the commands through the IRC. So you were allowed to IRC on a particular network. A bot sitting on that network now controlled the Trojans that were running on your network. Proxies were a good idea, though, and proxies needed to be built on because most of you guys know that proxies are not very friendly to traffic that's not pure for the intention that they were designed. At this point, we'll digress a little bit and speak about covert channels, because what we're talking about today is pretty much a mixture of the both. Covert channels are also, I mean, they're definitely not new. They've been talked about, they've been written about for ages. Way back in 85, Department of Defense Trusted Systems Evaluation Criteria defined covert channels as any channel or medium that allowed or exploited a process to pass communication through the network that beat the security control, that beat the security policy. Bypassed, beat.
Something like that.
In 96, Frack magazine published an article on Loki. Loki was named after the Norse god of deception and trickery. It allowed entire conversations to pass through ICMP messages. In 98, Van Houser from the Hacker's Choice published RWW Shell. A neat tool. What RWW Shell did was passed entire conversations through HTTP messages. And HTTP GET went across, and commands came back in the 404 error messages. The idea was a great one. It was built on in 99 by HTTP Tunnel. And what was then added was base 64 encoding. So now you've got a client inside your network sending out what looked to be HTTP requests, base 64 encoded, and it looks like it's normal HTTP traffic, but it's actually complete control, a Trojan within your network. This stuff was built on today, development still being done. Fire-through corporation, sell this device, sell you software that allows you to tunnel entire conversations through your network, making them look just like HTTP requests. The thing though is that while all this was happening, application layer gateways grew up as well. They started introducing proprietary authentication mechanisms. You got NTLM, you got NetWare's client trust model. So through all this, the application proxies were growing up, and the Trojans and covert channel bypass methods needed to grow up as well. A quick run through of the different methods and how they were and what happened to them. With the introduction of stateful firewalls and intrusion detection, you could forget about ACK tunneling, forget about ICMP tunneling. Guys wouldn't allow ICMP into their network anymore. Network tricks and direct models weren't so effective the moment you had stateful firewalls in there. Guys running through IRC and proxy servers, tightened firewalls, got rid of them. HTTP tunnel got taken out the moment your client needed NTLM authentication. And nowadays, with personal firewalls, with authentication, you try to fire up something on your client machine that wasn't supposed to be running, and the personal firewall is going to go ape. What we need is clearly a combination between the covert channel and the Trojan.
Okay. So we built something that we called gatslag. Now, gatslag is an Afrikaans word. The translation, loose translation into English means bummer, like just bummer. Gat means behind, and slag means hiding. Okay? And we thought that it was an appropriate name for this particular kind of Trojan. The Trojan uses covert tunneling techniques. And we will look today at how it bypasses the following defenses. I mean, it bypasses packet filters, authentication proxies, intrusion detection systems, personal firewalls, content protocol checking, biometrics, everything. We've tested this on different networks, and we find it to be working very well. These kind of mechanisms, defense mechanisms, how are they stitched together in a network? Well, probably something like this. Change the slide. There we go. Okay. So you would see there, you have a screening internet router probably there, a little segment there, firewall running NAT, doing stateful inspection, going into a DMZ demilitarized zone there, which is an unrouted network. You got your authentication proxy running there, maybe an IDS and a virus scanner, probably connected CVP here or there. You've got another firewall sitting behind the DMZ, connecting your private network through here, also doing content checking, that kind of thing. And you might have a PC sitting here with a personal firewall. We've got an unrouted network here, we've got an unrouted network here. Clearly, you can see that it's difficult for this controller sitting outside on the internet to reach the machine there. It's not going to happen. And what we'll show you is a method how we can actually get data between the controller here and the victim on that side. Okay. Okay, so how does Gatslag actually work? Gatslag uses also phone home technology. It makes a reverse connection to the controller. Data, again, is sent in HTTP requests and responses, so it's a HTTP covert channel. The difference here, the main big difference here, is we use Microsoft Internet Explorer as a transport. That is the main big difference here. Now, IE is not a foreign program. It's a machine, it's an application that sits pretty much on every desktop. Our Trojan never ever makes any socket call, nothing, none at all. What it does is it uses OLE to communicate to Internet Explorer, and it lets Internet Explorer make those requests and responses. How does it work? We surf, basically, to the controller, just like a normal user would surf. And then the commands for the Trojan is sent in a web page that is dynamically created by the controller and sent back. So commands to the Trojan is sent in small pieces of data that is in the title of the actual web page that we send back. And it's that data, with a GET request, the actual Trojan get that data. Large data, like files we want to upload to the machine, to the Trojan, is encoded in a special kind of, it's probably a little bit of a base 64 encoding. And it's sent as plain text into the actual browser's body. So if you surf to that page, normally you see a whole bit of text coming down, and that's just simple encoded text. Once that text is received at the Trojan, it's taken out of the body of the web page, decoded, and written to disk. That is for a file upload. For data that we want to send out, for a file download, for instance, we take the data that sits within the file, we read it, and we do a post. And with a post, we can send a whole lot of data back to the controller. And then we also have something like a heartbeat that is just sending with a GET request every now and again. It sends a little GET request out to tell the controller that it's still there. Let's see why it actually works well. Well, the biggest hurdle for this kind of technology is authentication proxies. Now, normally when you try to authenticate to a proxy using IE will supply credentials that it's got at that stage to the proxy. And there's two scenarios here. The first scenario is where the credentials actually match the credentials on the proxy. So, for instance, the user is already logged onto a domain controller, and that proxy is part of the domain. So the credentials between what is on the proxy and what is on the machine would match. And it's a transparent process. You don't see it happening. Actually, when you're logged into the domain controller, your credentials is already supplied. The second scenario would be where the credentials does not match. Then the proxy will send a request to the browser saying you've got to authenticate first. You see that little NTLM or basic authentication pop up on your screen. And the user types in the credentials there. And thereafter, the credentials are supplied. And the process, again, is transparent. You might say that is a problem for this kind of Trojan. What we can do is we can program it in such a way that it will detect if there's a session of IE running before it actually starts up sending data in and out. When IE is already running, you can assume that the user is already authenticated to the proxy. The other reason why it works nice is that you can bypass IDS just like that. Because it's a browser that we're controlling, we can do SSL very nicely. We don't have to program SSL into our Trojan itself because the browser handles HTTPS itself. So then we would make a HTTPS connection to our site. It would also mean that the controller on our site probably doesn't have the correct certificate for that site. I mean, that's just the way it is. So what we do is we modify the registry entry for zone crossings and warnings just before we surf to the actual site. So that there's no little pop-up coming up saying you're about to visit a secure site. Obviously, it can work without this. It's your choice if you want to use it or not. The changing of the registry could, in some ways, affect some kind of personal firewalls to pop up and say you're about to make a registry change. So you don't need it. What's nice about that is IDS is completely useless against this, as all the information is now encrypted with 128-bit SSL. Personal firewalls, that's actually an important part of the bypassing process that we want to do, because most of the Trojans out there is trying to communicate with the outside world via a foreign process. Now, stop that. I is not a foreign application, it's a known application. And the personal firewall is probably configured to allow that application to run A, and B, to go out in port 80 and to go out in port 443. If the guy actually does any surfing, that would be the case. His personal firewall would be set up in that way. Another thing that makes it great is it's totally platform independent. Microsoft has been so nice to put IE on every desktop nowadays. And the method of controlling IE is via OLE, which is a kind of standard way of talking to it. So it's really platform independent, and it's also version independent on the browser. You could have IE 5, 5, or 6 in there. It works fine with it because we're using OLE to control that. Now, one of the challenges, actually, of this phone home kind of technology is to find the way home, is to find out where to connect to. It's easy when you're running something like BO because then you connect to the thing. This, you have to connect out. You've got to know where to connect to. So the IP that we can connect to can be dynamic. And how does the Trojan then know what the new IP address is? What we brought in here is something that we call the principle of a master site. And the master site is a public web page. Could be sitting at GeoCities, could be sitting at Yahoo, wherever. And within that site, it's just a normal kind of web page. And within that site, encoded in the site, is the IP address of the controller. So what happens is, when the Trojan starts up, it first goes out to GeoCities or Yahoo, wherever. And it reads one kind of public web page, extracts out of the page the IP number of the controller, and then connects to that IP number. So if the IP number should change, then you just change it on your GeoCities homepage. Makes it nice. Yeah, let's move on a little bit this.
I think the main thing that needs to get across there is two things. Is the thing that makes Gatslag so nice is the layer of abstraction it gives us. I mean, you want to do SSL. No need to bother with SSL programming, as Roelof said. You just tell it, do SSL, it tunnels it through IE, IE will handle the SSL for you. Because everything's being pushed through your browser, all you've got to do is tell IE what to do, give it the data to push across, and it will do it.
Can we just stay there, yeah? A little bit stressful time as well. Okay, so we're going to move. Okay, how does Gatslag work? It's very simple. At the moment, we have it as a 33K UPX executable, no DLLs, nothing. Short and sweet. Let's look at the main loop of Gatslag. Well, first of all, we create an invisible browser. We then go to the master site. We find the controller. I send a request to the controller saying, I'm here, hello. If I don't find a controller, and I've tried 7 times or more to actually contact the controller, I would go back to the master and say, well, I can't contact the controller. Where is the controller now? If it finds the controller, it makes a request saying, okay, I'm here. And the controller would then prompt the user to enter something, the abuser, the guy that's controlling the Trojan, to do some command, sends the command back as a response to the reply. The controller then, the Trojan then receives the reply, pauses the reply, and decide what to do. It can upload a file, download a file, execute some kind of a command, any kind of functionality you can get in there, and then loop back. Just end on that slide. Some tricks that we've done here to make it work is we have to add some random data at the end of every request that we do, because what could happen is if you're going through a caching proxy server and you're doing the same command twice, then the question that you're asking, the request that you're making, is the same request. Okay, and so the caching engine would say, you already asked that question, here's the same answer. And so what we do is we put a little bit of random data at the end of every URL that we ask for to make sure that it does not get cached. Just hang on. It's very easy to change this as well, this whole process. I mean, for instance, antivirus scanners that would pick up on an EXE signature or an IDS that latches onto the data that's actually traveling through the line. I mean, getting the controller, getting the IP number of the controller from the master site, it can be encoded in any way you want to. It can be encoded anywhere you want to. The encoding of the files that we upload, you can do whatever encoding you like to do there. And what you actually want to do, you want to put in native crypto in the application itself. So you don't use the SSL, you don't do anything on the registry, but you crypt the thing natively in there, and then the IDS really can go home. Okay? Okay, so let's just see how the defenses for this whole thing fails now. Well, firewalls fail because if the user is allowed to surf the web, then the packet filters are probably set up to either allow that user to go out or to allow the proxy server to go out. We spoke about the whole thing of content level and IDS. The actual request that we're making is HTTP request, and those requests are squeaky clean because it comes right out of IE. Okay? We don't use any funny ports. It's 8443. We can encode our content as we wish, and even that, if we slap SSL on top of that, there's no way for the IDS to find it. For personal firewalls as well, IE is a valid application. The ports are normal. The user's probably okayed the use of that application, so that's cool. With authentication, either the user is already authenticated, as we said in scenario 1, or scenario 2, the user's stupid. I mean, sees a pop-up little window and says, okay, well, let's just put in my username and my password. It happens all the time. And then again, for that kind of problem, we can check for running instances of IE before we fire up our Trojan. The bottom line is this. If the user can surf the web in any way or form, Gatslag is going to work for sure.
Before we do the demonstration, we just want to say, I mean, we spoke to a few guys about this, and everybody asks us about delivery. We decided specifically to not go into delivery for this talk. We figure that's possibly another talk altogether on how to actually get the Trojan in. I mean, you've seen Trojan delivery now by email. It's stuff that guys download from websites. I've seen through someone's slides, everybody downloads, everybody clicks on the Anna Kournikova pictures. Take a famous website and put it on software that's available for download. I mean, if Apache.org was taken, if 2Cows is taken, there's guys downloading stuff from there all the time. There's physical access that Roelof spoke about. It's unlocked machines when guys walk away. I mean, a 33K file, to copy it on, execute it is not a problem. It's really not what we wanted to get into here. There's the final alternative that we always speak about is simply snail mail, is mailing a guy a CD and saying, what do you think of my software? And everybody runs it, and it auto-runs.
Yeah, they put it on the top of a magazine. They send the magazine, nice golfing magazine, you know, free kind of app for doing
improve your golf swing.
You know,
in
whatever.
5 minutes with this CD, and CEOs around the world run your Trojan.
Yeah. Okay, in the demonstration, the current functionality of Gatslag at the moment is we can list files. So we can say, give us a listing of a specific drive or directory. We can upload files. We can download files. We can do raw execution of programs. We also implemented here something that we call the DOS execute. And with the DOS execute, we actually do a DOS command. We take the output of that, we pipe it into a file. We download that file, and we show that file on the screen. So it's like typing a DOS command. You should realize when you do something like that, you get a little DOS pop-up running on the victim for the duration of what that command takes to actually execute. But really what you need to do there is you need to build that functionality into the Trojan itself. You shouldn't do it with a DOS command. We only do it with a DOS command because we're not really interested in actually, writing a Trojan. We're more interested in the communication, but we want to show you what the possibilities for that might be. So when we do the demo, you see there's a little DOS box that just flashes up and down. That functionality can be natively coded into the Trojan. And you can have any kind of functionality in there. You can do, sniffing microphones and video cameras, and that's just like the BO and Sub7 kind of things does. We just don't have the time or the interest to code that into our application. We're worried about the communication. And there's another function that the Trojan can do at this stage, and that is to quit. Very proud of that. Okay, in the demo itself, what we'll do is we're going to list a C drive of a machine. After that, we're going to upload a keyboard logger by Arne Wittstrom called klogger.exe. We'll rename that file to the right directory and file. Raw execute that. Haroon here will type in some ARB text onto a notepad. And then what we'll do is we download that logged file, download it back again onto the machine, check it out, see what it looks like. We'll show you how we execute some DOS commands on the Trojan. And then if all goes well, we'll also move the controller. So what that means is we'll change the IP address. We'll change the IP address of the controller, and the Trojan must then visit the master site once again and pick it up. And Haroon is writing something here that I must now
read at some point.
Time is fine.
Yeah,
okay.
Don't rush.
Right. This is a...
Okay. When we planned this demonstration, I must tell you, we originally planned with a firewall in between the two. Unfortunately, when we arrived here 2 days ago, we did, and our luggage didn't. Then our luggage did, but our firewall didn't. And unpacking the firewall means we've got the box, but nothing on the firewall works anymore.
The power supply is gone.
We think it's the power supply. The stiffy drive came in sideways, so we don't know what happened to that box on the way here. So the original box had the firewall sitting in the center here, running intrusion detection, running content level checks. We've replaced it now with simply a gateway box that only passes communication one way. So effectively, the victim notebook on this end can only go out. No communication is allowed back. I mean, it's not rooted. So it's a poor substitute for the firewall that we did have running, but I think it'll prove the point just the same, or we hope so. Okay, we're just going to switch over so that we can do the demonstration quickly.
You're going to take the video stuff.
Okay, one of the other changes that we've made for this is, for fear of going out onto the internet, okay, remember that it needs to connect to a master site. My site, for example, needs to connect to a master, the one that Roelof spoke about being on GeoCities. It needs to connect to this GeoCities page and say, who's my controller? So the moment the Trojan executes on my end, it needs to know where to go. So what we're going to do in this case is actually execute that website here. What we've got is a simple text file. I'm not sure if you guys can read this. All it does is in the title, it says control and Roelof's IP address. I'm just going to pipe this to a netcat.
Just hang on before you do that. The thing is he's basically, the version that he's got on his machine is saying that the web server, the master site where he's got to connect and get the IP address for the controller, is locally on his machine itself. So it's going to surf on the loopback interface to its own IP address. And we don't have like an IIS up here. We just have a netcat that listens on 80 and that will push that through the pipe that we're setting up.
It'll also give you a chance to see the request as it comes through. And what you should also see, seeing as how this is the victim's PC, is zone alarm. Zone alarm coming up and saying, dude, something is trying to listen on port 80. It doesn't usually. Okay, that's because this web server is supposed to be sitting out on the internet somewhere. It's not running on the victim's machine. You're not going to find the possibility of contacting someone and saying, can you please run a web listener on your machine because I'd like to Trojan you. It would be nice.
The funny thing is, just before we go on now, this is not part of the original plan, but when we were testing this thing, we now found the best way to actually propagate a Trojan and to Trojan someone. The best way of doing that, you contact them and saying, you know what, you've got a heavily protected network, I know this, and we're speaking at Black Hat, can we test something on your network? Like, yeah, no, sure, you go ahead. So,
Okay, so we've got the listener. All I'm going to do now is execute the tiny,
that one.
okay, you see it come through. It went ahead, asked me for who it should talk to, and went straight back to Roelof. That's me starting netcat again.
Okay, so you see on this side, it says the net buyer's name, Shadow, that's his machine, is online. So now I can do, for instance, an L for listing. And I'm going to say, list me everything in C. And that's his C drive there. And I want to do upload. I'm going to upload the keyboard logger. So I do U for upload. And I say upload klogger.exe. It does the upload actually. Okay, once that is there, I now want to rename that file. That's just because I was lazy when I actually implemented this thing. You can maybe expand on that.
Roelof's lazy. There you go.
Okay, so we're going to copy that file, which now sits in C when nt upload.clx to cklogger.exe.
Okay, by default, it puts the file in your, it takes from your environment variable the window. We didn't know where to put the file. I mean, what if the guy whose machine you're running on doesn't have C Windows or C WinNT or C temp? So we write it to we write it to the window. It'll put it in whatever your Windows directory is by default.
Okay, and I'm going to execute that now, klogger.exe. And now it should be running on that machine. If you can just open up a
What this means is, we originally started off by writing a keylogger of our own specifically for this, but found it wasn't worth the effort, because what you could actually do was take one of the best keyloggers that they had out there, or take the keylogger of your choice, and then just use that. I mean, all you're doing after that is taking the keylogged file. This is where I add pointless text.
Okay.
Okay, it's a standard keylogger. It should grab all the stuff that we do.
So on this side, I'm going to list all the files in temp and see if it's there. And you see there's a file now called klogger.txt, which I'm going to download now. So I say download c temp klogger.txt. It downloads it. I can quit on this side. Just could do a Control C. Oops. klogger.txt. And there we go. That's the stuff that he put in there. At this stage, I can now again execute this. It will reconnect to me. There it reconnects because it sends a heartbeat out. This is the heartbeat. Just picked it up and say, I'm here again. And I can execute a DOS command. Now, look at that screen and see when I execute the DOS command. I'm just going to do a set to get the environment variables. You see that flash there was the DOS command actually executing. And within 10 seconds, it takes 10 seconds to actually see if the command can finish. It gives it 10 seconds to finish. And then I get the actual output of the DOS command on that side. Now, these networks can be obviously, this works. We've tested this network in various, the setup, we tested in various different network kind of types.
We tested it against one guy on IRC with his permission, who was going through a toll-free number locally in South Africa, going for some reason, popping out, I think, in France.
French network, yeah.
Coming out against multiple NAT boxes, which he thinks were doing some sort of checking because he couldn't do anything else and had restricted site access. And it worked fine. He didn't like it too much when Roelof pointed out that his mother was on IRC talking to someone about Bulgarian clothing.
Yeah.
One of the advantages of the master being written in Perl is that, for example, when our demonstration crashed because of the firewall that didn't make it, all we had to do was put active Perl on that Windows box and it ran just as well. It was designed on a FreeBSD box. All we did was throw active Perl on and the master was good to go. It means that you can make your master site just about any machine in the world.
Controller.
You can make the controller just about anything in the world. You can put your master site just about anywhere.
Yeah.
I mean, at the moment we netcat listening. It could have been at GeoCities, could have been at Yahoo.
I think what we want to do now as well is Haroon is now going to change that file so that it sits on a new IP address. I'm going to move my IP address away, and let's see if we can still get the thing to reconnect to the master. Then from the master, get the new IP address and reconnect to me. So I'm going to quit at this.
The whole point of it being Roelof's dial-up machine needs changing, or the machine that he was using, he's not got access to anymore. So all we want to do here is simulate a different controller. Roelof's going to change his IP, I think, to
250.
50?
I'll change to 250, yeah.
And all I'm telling my netcat is, look, do it again, but this time you're going to be pointing the controller side to 250. Zone alarm again, excellent when you don't need it. And within a little while, Gatslag's going to say, I can't get to my old controller. There you go. It comes back, asks me for the new master site.
And we got it on that side. It now connected to the new IP address because we changed it there on the master site. And I can go ahead and do whatever I want to. At this stage, I'm going to do the delete quit on that. And it quits it here and it quits it there.
That was just Roelof wanting to be a software developer. Ask him, please enter to really quit.
No, but fine. Okay, let's just switch.
Okay,
I just want to switch back on the monitors. The demo worked. Oh, sorry.
That's because you.
Okay. Not. Didn't work, man. Okay.
Okay, so let's see how we can take this further. Obviously, what we want to do is we want to use this Trojan that we've just written to now connect to a different machine. Why? Because we maybe Trojan the typist in the organization, and the typist machine is not that interesting. We recorded keystrokes, and we maybe got the credentials to the mainframe, we got credentials to a Unix machine, and now we actually want to connect to that Unix machine. What we basically want to do is we want to use the machine that we Trojaned as an attack platform into the rest of the network. Now, what we would like to have to do is get a network level access, network level kind of tunneling, but that's kind of difficult. So let's go to session level. Now, just to explain to you what's happening, we have the controller sitting here, and the controller is talking to the victim through encoded web pages. The victim talks back via post replies and post request. This side, on this network, which is probably an unrooted internal network, we want to use normal socket calls to do a send and a receive from there to there. And on this side, from the client, we want to do a send and receive to the controller, so that it seems that the client is really connecting to the server through the internet, through all of this firewalls, IDS, all of the above, and that you really have a connection between these two. So let's just have a look and see how the flow control would work in something like this. It gets a little bit hectic. First of all, you will have the heartbeat get coming from the victim to the controller, right? The abuser, the guy sitting there at the actual controller, then enters the proxy command. The proxy commands, the parameters for the proxy command is the local listen port, the remote IP, and the remote talk port, where it's got to connect to. Then what happens is the controller starts to listen there. The controller starts to actually listen on that port for incoming connection. The controller does not reply to that get until it gets a connection from the client coming in. And it replies then to the victim with the parameters there. That is the parameters that was entered. And the victim then knows where to connect to, correct? Haroon, I can't get the laser pointer through your head, man.
Use that one. My head's not there.
Yeah, but...
Okay, I'll move. It's cool.
It's okay. Okay, so... Yeah, but then my notes is here, and then... Fuck. Okay, so... Yes, toch. Okay, then Where are we now? Okay, so we do a TCP connect there to the server. We do a receive back. Once we get that data, we encode it into a post request. We send the data down here. At this stage, we do the send back to the client. Remember, we already have the connection. We do the send to the client. We receive back from the client. We take the request. That was a request. We populate the reply to that. And then once we decoded it here at the victim, we send it via normal socket call to the server itself. And this process is repeated over and over again. Next slide. This is not easy, doing this. There's difficulties with this. Why? Because this is not really HTTP tunneling. Because like Dove is not a SOAP, like a browser is not a socket. Okay? You can't do a select on a browser. That doesn't work like that. You can't do a natively a select on. You can't do the flow control on a browser. So what we're actually looking at is a kind of a train model. Okay? At the victim, the crates are loaded on top of this train. The train is sent to the controller. Maybe you just want to go to the previous slide. Okay, so the data is loaded onto the train. The train is sent here to the controller. The data gets unpacked and sent back to the client. And the client then packs the stuff onto the train again and sends it into the, sends the train back. So, okay, you can go back. And it goes back to the victim. But what happens when the server or the client is sending data while the train is on the other side of the road? It's there, right? Now I want to send data, can't get it back. Now we've got two scenarios, two problem scenarios. Okay, the first problem scenario is the controller cannot send data. Remember, the controller only responds on a post. It can only respond, it can't send. So it's got to wait for the train to arrive and then send the stuff out. So what we need to do there is what we need to do there is just go back to the slide. When this connection is made and the client wants to send data, as soon as the connection is made, we got to buffer that data. We got to keep it somewhere in a kind of a cache. And as soon as the train comes along, we throw the data on top of that thing and it runs out. We can't really do that at the victim side. Buffering is not feasible there. Because let's say you execute a command like a ls, you have a telnet kind of session running, you do a ls there. What's going to happen is if we buffer the data there, all of that data has to come back. And once it's gone back, you only see the output in one big go. You want to see the data coming interactively back. And the problem with that we have here is that let's say there's something being sent down here or received here that's been sent now through the post to the client. And that particular data does not create a reply. So let's say the client says, no, wait, you send me more data and then I will reply to that, which happens all the time. That process then stops over there because it can't receive anything. It's nothing to receive. So what we've done there to fix that is to use what we call multi-part posts. And what would happen is as soon as the victim sees that there's more data on the line coming later on, it sends a flag that says, this is a multi-part post. And at the controller side, it will then immediately respond with the empty encoded web page, just saying, yeah, okay, I've got that, you send me the rest. And that tends to work. The problem with this is really that it doesn't work for all kinds of protocols. For instance, HTTP is a big problem. Remember, now you're running HTTP over HTTP. And you get multiple connections coming into the controller. And you only have one train going up and down. So it's kind of difficult to keep track of all these connections and that. At the end of the day, we're not programmers. Okay? So we have difficulty with it because it's a kind of a technical difficulty. It's not a conceptual difficulty. It works. It's a fundamentally, this thing would work. But technically, between me and Haroon, we kind of struggle with the C++ code for that.
So it works for some of the simpler protocols that we can test it on. We've got one that runs in proxy mode like this. You can go across, get FTP banners, stuff like that. I think what Roelof's aiming for is total being able to do FTP transfers between the two, stuff like that. And those are limitations that, one, we didn't solve, but to our defense, we weren't trying to solve it at the time. We were saying, this is what can be done, guys. Either you go out and do it, or just know that it can be done, and there's probably people doing it already.
Now, the other problem that you had with this was you encoding HTTP within HTTP. So when you start doing the parsing to find out where is the header and what is the body, you now have header, body, but your body is in fact a header again and a body. So you've got header, header, body. So what you need to do then is you need to encode that post request as well, so that you have header, and then you got encoded header and encoded body. And that works fine. We sorted that out. It's the multiple kind of connects it. Yeah.
For solving the problem, one of the problems we had was when we went to the guys with this and they told us you can't go to Black Hat and not give the guys solutions for the problem. So we listed a few things that we thought would work. The first thing is, like I said, what we stayed away from, and that was delivery. It's still your best defense. Cutting the stuff off before your box gets infected is always going to be first prize. If you can find a way to tell me that you can make sure no one in your company is ever going to double click on the Trojan, then I think you're excellent. You're one stage away from total bliss. The second, more workable option is that of whitelisting. It's not one that makes us very popular, because we'd hate it if we were on a network and people told us where we could surf. But I think it's becoming a more real alternative. With your firewall rules at one stage were default accept, and people denied specific kinds of traffic. Nowadays, it's almost non-existent that you'd find a firewall rule base like that. It's default deny, and then you say, okay, this kind of traffic is acceptable. And I think one of the things you could do in a corporate environment is say that, look, no web browsing's allowed unless A, you're going to corporatenetwork.com, B, you're going to one of our business partners, or C, you're going to CNN. That's all you're allowed to watch. It's a workable alternative, and it kind of mitigates your risk. The third alternative that we come up with is user education, and I think this one's the most important. I think one of the problems technical guys have is we constantly try to find technical solutions, and lots of the problems aren't really going to be solved technically. Lots of them come down to, at the end of the day, to user education. If you can teach your users that they need to inherently distrust software, that they know nothing about, if you can control them double-clicking every attachment they get through in the email, it's going to make a big difference. And I think system administrators should need a bit of user education here as well, because I mean, very few sysadmins look through proxy logs. Very few system administrators are checking logs actively. And checking logs actively, checking them yourself, makes a big difference, because you can pretty much spot traffic that looks suspicious. 5 meg posts should raise eyebrows with whatever system administrator you've got. The last alternative that we chose was just a message out for the guys developing antivirus personal firewall solutions. And that's just that very few of the products that we've seen check, for example, for registry changes. Very few of them noticed when we changed the zone crossing, for example. Maybe start checking every time an object gets spawned invisibly. I mean, why does an object need to get spawned invisibly like that? Even keeping a tab on running processes. Just something that'll make guys rest a little bit easier if they're running personal firewalls. And the last question is just the one that hurts the most, is deciding that surfing the net is, while you're at a corporation at any rate, is really a privilege and not a right. And maybe everybody out there doesn't need to be surfing the net, exposing you to this kind of risk.
Oh, for sure. Okay, in conclusion, they always say that the conclusion and the introduction must, tie up. I hope that's not for us. In Contact, the movie Contact, Jodie Foster says, in the last scene of Contact, she says, yeah, all these stars, you know, there's millions and millions of stars in a galaxy. How can it be that we don't think there's intelligent life? The people that saw the movie, they would know what I'm talking about. Now, think about this. We are not programmers, okay? We took 2 weeks to write this thing. It was clobbered together with Google, duct tape, and spit, okay? It took us two weeks to write. We had no budget, and we had no MSDN. All the components that we use exist on the net today, all of it. We don't think that me or Haroon is particularly stupid, but we don't think that we're the most clever person out there, and we're sure there's more clever persons like us around. We don't really have motivation. Our only motivation to write this and to develop this and to spend a whole lot of time on this is to get on Black Hat. And other people, if you think about it, they might have all of this. They might have a big programming team, a lot of budget, they have real motivation to do something like this. They might be very clever, and they have a lot of time to do this. And so how is it that something like this is not already out there? I think the chances of that is slim. So the idea with the whole presentation was to make you aware of the power of applications such as this, and to make you aware that something like this is probably there, and methods to defend against this kind of thing. And I think that is the end of the presentation.
And seeing as how we've got time, Roelof will now field any questions that you have.
Right. Is there any questions?
That's about it.
Okay, well, that's it.
Thank you very much.
Thanks for your time.